Hello and welcome to this webinar, How F&B Manufacturers Can Benefit from Using MBR. This food engineering event is sponsored by Integrated Water Services. I'm your moderator, Derek Teal, Editor-in-Chief of Food Engineering. Thank you for joining us. Today's presenters are Christopher Dooley, Chief Commercial Officer at Integrated Water Services, and Val S. Frankel, Vice President of Greeley & Hansen Water Solutions. Prior to joining IWS as Chief Commercial Officer, Chris served as President, CEO, and board member of DMP Corporation, a leading provider of wastewater treatment, water recycle, and reuse solutions. Val is well known in the water industry with his expertise in water and wastewater treatment, water reuse, and membrane technologies, including desalination. Developing, leading, and delivering nearly 300 projects globally, Val's works have been published extensively both in the US and abroad. And if you visit the Handouts tab on your screen, you can download the white paper, Turning Wastewater into Value for Your Business, which will also help supplement today's webinar. Don't forget to submit your questions, and later in the program, we will address as many as possible. Today's event is being recorded and archived on www.foodengineeringmag.com/webinars. Now I'm excited to turn it over to today's first presenter, Chris. Chris?
All right, thanks, Derek. Appreciate it. So just to start the conversation off, I just wanted to quickly provide a context, which I think many or probably all of the folks listening in are fairly aware of. But just to summarize it and set the stage for our conversation that will follow, there's a number of different things that have changed over the past 5 to 10 years that create a unique environment that makes MBR a pretty compelling solution in today's food and beverage manufacturing world. To quickly go over those, right? The first one is environmental impact and its impact on the brand, right? So food and beverage manufacturers, as we all know, large users of water, and the large water users in any locale have a real impact through the depletion, their impact on the depletion of water resources. We've all probably seen the New York Times article that came out not long ago that talked about the grave state of our freshwater resources and how rapidly we've depleted specifically the aquifers out there, right? This not only has an impact on people living there, but it's also habitat destruction for local wildlife. A great example of my native land of Northern California, where a lot of the water is diverted to the Central Valley in Southern California, and there's usually a very public fight over that's impact on local fish populations, right? And then, of course, the all too common pollution that comes up for our local freshwater sources. So increasingly, consumers are really concerned with how the businesses that they do, whose products they purchase and they use and they buy, how do they protect these valuable resources? What kind of an impact are they having on their local communities? And so, as a result, right, sustainability goals have gotten a lot more ambitious and really increased over time. So we're really having to be much more conscious in our manufacturing efforts about protecting local water resources. Second is increasingly stringent environmental regulations, right? As there's increasing awareness at both the local and the national level of the impact on scarcity and adequate clean sources of water, rather, and its impact on the local population and the environment, right? How does that manifest itself, right? Regulations get stricter naturally on both water usage as well as disposal, right? Please use less and keep it cleaner. Third is water scarcity is becoming more common, including in places where they were used to having almost unlimited access to clean water or minimally water with minimal treatment necessary to use in an industrial environment, right? So at a global level, demand for clean treated water is outstripping supply. Although water supply is fundamentally a local issue, you combine this with changing water patterns, right? And you used to have access to it. Now you don't. And this really matters. If you planned your optimal production of your facility based on a use of 1 million gallons per day and your permit now only allows on 800,000, that's a real impact on profitability. The other is economic pressures. We're always asked to do more with less from a resources perspective. Water's not getting cheaper. While they do tend to be, U.S. water rates tend to be among the lowest in the first world, they're rising fast, along with the cost to pre-treat the water for use in production, as is the cost of sewer discharge. So you put all those together and water conservation becomes increasingly front of mind for food and beverage manufacturers. So people aren't sitting on their laurels, right? There's a lot of things that you can do, and I think food and beverage manufacturers are already doing to react and adapt to this new environment that I just summarized for you. Some of those are pretty basic, right? You start with just doing a water audit, go through the plant and understand how and where you're using it, put in new SOPs to make sure that you eliminate the obvious waste, like just leaving a hose on after cleanup as you've moved into other tasks, right? It's getting a little bit more technologically savvy and using sensors to proactively identify and address leaks. And then, of course, the part that I think we are here to talk about is using more advanced treatment technologies to be able to comply with these increasingly stringent discharge requirements, and also to be a better conserver of water by recycling, reusing it back in the plant in a number of different capacities that we'll talk about in more detail. But there's a lot of ways in using more advanced treatment that you can do this: irrigation, makeup water for your cooling towers, for boilers, first wash down of your production equipment, using it in restrooms, dust control, etc. So with that as kind of setting the stage, I'm going to turn this over to Val.
Okay, thank you, Chris. So we would like to talk about the MBR, and which is membrane bioreactor. As you may well know, is generally a coupling of the biological secondary process with the membrane separation, not to be dependent on the flux size of the sludge, separate the liquid stream from the solid stream, and we are using the membranes. The MBR is started to be commercialized nationally in the United States in the 1990s. Mainly, even the technology has been invented or developed to the more the limited application early dates, but that was we're considering as a starting date of the technology to be adopted in the industry. And as we can see, that market is quite expanding. And it's quite interesting that depending on the market conditions and purposes, we've seen different drivers as the technology being adopted and developed in the years. Here just shows some milestones from the beginning in the 1890s, and it did attract attention in early 2000 when the MBR was as technology comparing to any other biological treatment needs less footprint or less space to be installed. That was the very good application for expanding the existing facility, which were limited in a footprint. If, for example, between the housing or any developed area and the river where water needs to be discharged and so on. By about 2010 or next decade, the energy, we've seen the quite hiking on the energy price, and that probably slow a little bit attraction to the MBR, because as MBR is more dense technology regarding the sludge concentration, it may needed more energy. And as the oil prices went up, that a little bit relaxed the attention. However, with the improvement MBR, it came back to the interest. And nowadays, we've seen more and more traction to MBR because the technology developed, well commercialized, more players came to the market, and the MBR is providing significant benefits to the treatment of the industrial wastewater, and specifically for food and beverage. And we would like to share that experience with you and provide you some case studies, what we've seen. However, we would like to learn what obstacles some people may have or seen that actually prevent to develop MBR technology. And here's a sample. We identified 7 actually probably major roadblocks to consider MBR, and please take about 30 seconds to fill in. And I will share you, if you will see the screen, what are the results. Please click on that. What do you see there, obstacles for you or for your organization to add MBR to your portfolio? Okay, so we have to now. Actually, generally, it's a high investment cost, a capital initial cost, and second, lack of experience and knowledge. Okay, let's walk through that presentation on a further and talk about advantages. So here are that 10 advantages that MBR, unique advantages that MBR can bring compared to any biological treatment or comparable biological treatment. First of all, the effluent quality. The effluent quality from MBR is very superior. Even the Title 22 require the turbidity from the MBR membrane treatment at least to have a 0.2 NTU comparing to the conventional filtration 2, which is 10 times high. So, and the reason is quite simple, because we have the ultrafiltration or microfiltration membranes as a final process or final stage of the treatment in MBR, similar like ultrafiltration or microfiltration membranes on any tertiary treatment process. The smaller footprint, as you may know, the MBRs can run on a much higher liquor than activated sludge, which we consider in the average number 3.5 gram per liter. MBR can run 8,000, 10,000, or even high, depending on the application and how you designing it, how high you need to go. So, and as you may know, the volume of the biological tank in reverse proportion to the mixed liquor concentration. So roughly, if you compare a 3.5 gram per liter in a conventional to 10 gram per liter in MBR, theoretically you almost need 3 times smaller biological tank or all your equipment. The MBR, the most of the system, even the medium size, and they built as a modules. So generally, it's a module expandability, and the membranes can be contained in a separate tankage from the biologicals, which can be installed at the site, and containers can be prefabricated up to quite a high volume of flow. And now it's available capacity, even counting in MGDs per one container, one skid. So the energy overall, it's quite interesting. So with all advancement with the MBR, and those are different actually supplier offered a different concept. It's quite reduced energy usage, again, comparing to the initial MBR installations and the maintenance requirements. So what happened, the MBR from the process standpoint can be fully automated. So comparing to the biological treatment activated sludge process. So, and it can be PLC controlled, monitored, and controlled. So generally, even the small plants, it's not, it's quite known. You don't need to, again, the operator assistance or attendance needed. So to check, to verify at a certain point, to take control samples at the end and so on. However, it does not need to be 100% present at the facility. Again, is a small. So that it's quite competitive from the sustainability practice. And one of the drive now, the MBR, is actually a good fit to the reuse projects. And the reason is that MBR effluent is just one technology, but effluent quality is high quality tertiary effluent already from one technology. And if we want to go to the potable reuse, again, it's maybe not a demand in a food and beverage, but actually that can be added to the tail of the process, having that feature that MBR can provide. It's mitigating financial risk and regulatory risk, and MBR is very flexible in terms of liquor concentration that the MLSS and sludge retention time, SRT, can be very widely operated within MBR system, and that allows to provide deeper nitrification compared to any other process. And the reason is that in the MBR technology, membranes are actually the separation barrier between liquid and solid stream. So we are not dependent on the settlability of the sludge or SVI index, as you may know. And it's quite important too. MBR is provide disinfection at the same time, because the water, the bacteria may not pass the membrane, again, if the membrane integrity in place, and that confirmed, and not all viruses can pass. On the, just it's a physical straining. Yes, MBR does need secondary barrier according to all regulation and any critical situation, whichever may happen. However, the demand in disinfection is a way that is by chlorine or ultraviolet is less comparing to any other technology. So less chemical may be required. I'm passing to Chris back to talk about the compare MBR with other technologies of interest. Chris, please take over. Okay. It looks like as Chris has some issue to connect in. Let me talk about that too. Actually, the MBR, we compared MBR with moving bed biological reactors and lagoons. Those are quite adapted in the food and beverage industry. And you can see actually it's in many aspects the MBR can provide significant benefits, as you can see of that slide there. Effluent quality or treated water quality is much higher on MBR. The MBR is the produce less sludge, so it's more efficient. It does require much less footprint compared to other technology, so the space requirements is much fewer. And the MBR is quite robust technology, and it's better can be controlled and monitored as the product that can be that need to be achieved. So in terms of reliability, footprint, and effluent water quality, MBR is actually more advantage. Yes, it does need more energy. However, that's what you need to pay to get all those other benefits from MBR. So how the MBR is applied in the wastewater reuse. At the top of that block diagram, you can see that just comparing to the conventional activated sludge process, the bioreactor that followed by clarifier, we have a recycled sludge, and we have some extra waste activated sludge. If we want to achieve the high quality water, we can use the low pressure membranes, microfiltration or ultrafiltration membranes. And if we need to achieve more tight criteria for the treatment, addressing dissolved matter on the water, we add in RO to the tail of that process. It can be RO on the full stream, or it could be part of the stream, depending on what we want to achieve. For example, if you wanted to get water quality certain to achieve certain salinity level or certain specific components in the water, like a boron or something else, depending on the criteria, we can use the RO as a partial stream only. I'll give you a good example. As an example, if we want to, if we have a source water that come into the plant facility, for example, 500 milligram per liter salinity. As you may know, wastewater, just to treat WHO standard, as we know, the wastewater usually add salt in a range 150 to 250. What may happen that not may happen, but will happen. The wastewater that will be leaving your facility will have salinity up to 750 to 800 milligram per liter. And if that water goes to the irrigation, and specifically like in California, the citrus product irrigation crops, they are not the just magic number is not to exceed 700 milligram per liter. In other words, we need to cut off some salinity. In that case, you can plug in partial area. So the MBR, as you can see, they combine all those three major components on the wastewater treatment plant: the bioreactor, clarifier, and tertiary, and we have all that together in one place in a smaller footprint. Again, all those benefits that we already listed 10. However, we may need to pay extra energy for that. And similarly, RO can be plugged at the tail if we want to achieve the same results. So here's another interesting point. What, as you heard probably, is quite a lot on the media, at least within the last several years, that PFAS is a big concern. So it's the PFAS, the separation. We know PFAS separation technologies, and we know that RO is one of those premier as a separation, but not destructive. So what's interesting, if you're using the MBR, which is good pretreatment to RO in a wastewater reuse application, you can plug RO and you will end up in a concentrate stream. So what's interesting, that to destruct, and most of the PFAS, as you may know, are removing reports are that more than 95 or even higher PFAS rejection by RO membranes. And as you may know, that the PFAS destructive technology, they're quite expensive. So the less small, so by using RO, you minimize the flow of the water with PFAS, which will be RO concentrate, not the entire stream. And if you have RO recovery 75 or 80 or you have 85%, you actually ended up in 15 or 20% of the entire stream with PFAS to be treated. So you don't need to treat the entire 100% of the stream. And you can apply the foam fractionation or any other more concentrated technology for PFAS and send that to destruction to plasma or any other destructive technology. So this is quite interesting concept that actually they eliminate PFAS from your waste stream. Now let's go to another case study. And let's look at some scenario. As an example, food manufacturer in California. As you may see that it's a very high organic load, very high salinity load, and the water, the treated water can be applied or just internally, which low salinity, like below 500 milligrams per liter, and no BOD. We need to remove the entire BOD and COD, which, as you can see, can be up to 70,000 milligrams per liter, which is actually enormous. And anything whichever removed from that facility cannot be actually discharged to environment. So we need to produce clean water with low TDS below 500 is actually like a potable water to make it for any reuse or even discharge in that area. We're talking about Silicon Valley in California, where, as you may know, that salinity is a big issue and it's always challenged to discharge. So I don't want to dive to all those complicated processes. You can understand that 70,000 milligram per liter, even prior to MBR, it needs to be applied the anaerobic digestion process, the combination, and actually it been done just on the mesophilic, but it could be actually applied in a concept of thermophilic with mesophilic, two phases in that scenario. And what's interesting that actually the process, including the MBR prior to RO, it worked well. However, the hardness was one of the limiting factors of the MBR. And for this specific project, let me show just some examples. Here, as you can see on the lower picture here, is the scaling accumulation of the phosphate, calcium, and magnesium, that actually completely plugged the old piping in the RO system or around the RO system, which is critical. So generally by adding another step process as ion exchange, so that as shown here on the left graph in the blue, if you can see those initial concentration, and on the bottom graphs, on the bottom charts in both graphs, actually, the concentration of the hardness ion that have been very completely removed. So by actually removing the hardness, that limited the RO recovery. And again, we need to focus always, at least the major rule in RO, to have as much as possible the recovery, and in other words, to produce as much as possible the clean water and reduce the rejected concentrate stream from RO, and to dispose it properly or treat it, whichever the option is available. And with that, I believe we ended up with our presentation, and I am turning back to Derek, right?
Awesome. Thank you so much, Val. And we're still having issues with Chris's connection. I believe we're getting him back just now. So thank you both for the presentation. And before we address those questions that we've gotten to throughout the program, I wanted to remind everybody that we'd love your feedback, and you can provide that to us in our webinar survey, which we will then use to help improve our programs. Again, we've got plenty of time to answer questions. So if you do have a question live for Val or Chris, please get that on into us, and we can ask that live. Obviously, if you do have any questions, either in after the session, viewing during the recording, we can get those responses to you offline post-event. Okay, so we do have Chris on. He is in our backup line. So we can start asking those questions. So the first question is, so are there regulations around reusing the same water no matter where your company is located?
Chris,
yeah, hi.
is Chris available?
Okay. Yeah. Can you? Hopefully, everyone can hear me. Val, thanks for picking up in my absence.
No problem.
So I think the short answer really is, look, regulations are going to differ from locale to locale. In some cases, the limits for land application or other types of reuse are quite low. If you take a look at, say, the Napa Valley and the winery, where you're looking at $500,000 an acre, they're very, very strict in terms of what that water can look like after treatment before you can put it on, before you can land apply it. And from a safety perspective, this is going to be a little less local and a little bit more internal, as well as driven by national regulations in terms of how clean that water needs to be used on equipment that will eventually touch any type of food or beverage manufacturing process, right? So there's an element to local when we talk about recycle and reuse. When you're talking about just land application, that's going to be driven mostly by local standards. It's going to be a little bit more national when you talk about reusing it internally on process equipment. Val, I don't know if you'd like to add anything to that.
No, that's right. Yeah, good. Thank you.
So where would somebody go to figure out what regulations affect them and where they would go in their area?
There's lots of different resources and websites in your local regulatory body or at the national EPA that you can find. I to be honest, I don't have the link in front of me that I could read out. Unfortunately, I think someone else might, as I'm unfortunately on the backup line here.
Yeah, just to add here, it's quite interesting that we don't have a national water reuse regulation. So each state adopting is each own. So you need to connect to, depending on the state, you need to go to the water board and to check what is the current status. And actually, Water Reuse Association actually collected. There is posted information on the states and addresses, how to check and how to find the regulation in each state.
Is that something that's common across the world, or is this something unique to the United States in that there isn't a national set standard that, and then it's down to the local level?
It depends on country. So because it's really depends on country, because generally we as the United States, each state is considered practically as a almost independent state. So the point, no, most of the countries around the world, they have a one common regulation for the country. So we in quite unique situation. We have 50.
Wow. And so this question's asking, how do I know the ROI for reuse projects to justify it to management?
How do I know when the reuse project ROI? You need to do some evaluation. So generally, it's the evaluation. Some studies done. It's tabletop, so you can calculate the cost, the benefit, if financial, and the first not as we put the poll at the beginning. So not the financial drivers for the water reuse. If you need to treat water to reuse quality are financial. So there's several other criteria. Plus, it's a lack of the water. So usually, how that's been done, you can calculate about the cost of the capital. You calculate of the cost of the operation. Plus, you need to subtract cost of the potable water that you need to purchase from the utility or export by yourself, because as much as you use in reused water, you actually displace the use of the potable water, if that within your facility. So, and based on that, you calculate in your ROI. And the shorter ROI, the better, or you can better justify. This is from the financial standpoint. So another point, it's quite interesting what we've seen in many places. For example, if certain facility needs to expand the plant, capacity of the plant, the business grows, and you need more water for operation, you may not get that water from your supplier. So you may have just no choice but to justify to investment to increase your use of water, free up your potable water supply, which may be not available, or it will be very prorated rate to pay that your ROI will be very short.
I don't want to assume that this is accurate, but in areas where there are greater water restrictions, would there tend to be a shorter ROI?
So I don't know if I'm answering your question exactly. You're building on a little bit on what Val said. Is when you look at it just from a purely economic ROI, the cost of water is pretty cheap in the U.S. Even in those places where it's a little bit more of a dear resource and has increased 5 to 10 times over the past 5 years, it's still on the whole not super expensive. And so the savings on water volume alone aren't probably going to get you to a great financial return. However, I think Val hit it on the nail on the head. Where you get the real financial return is the ability to operate at optimal capacity when your access to water resources is restricted due to water scarcity, and that's where you really, and then for your increase in production, and efficiency in the plant is going to be huge. And also the other impacts are on your brand, which are a little harder to quantify, but are no less real from an economic return perspective. So having aggressive EH&S goals, like, I don't know if it was mentioned before, but a lot of very large companies are very vocal about their water savings goals, and like PepsiCo, for example, right, where they want to be net water positive, I believe, by 2030. A lot of other brands have equally as aggressive goals, and there's no way to get there without investing in recycle and reuse projects. And when you do so, right, that increase in that, a boost to your brand, and therefore the follow-on increase in loyalty from your end customers, is another part of that ROI that's hard, again, harder to quantify, but no less real.
Good point, Chris. Good point, Chris. Just to add to that, so many large corporations, at least all that we're working with, they have a corporate mandate, like Chris already mentioned, by certain year to be water neutral or reduce water footprint, we called it, and reduce the energy demand and so on. And more of that, those corporations to reach the sustainability goal. Not just those corporations are setting those goals, but they demanding from all the entire day supply chain. So they're all smaller company that work for and with those corporations need to be abiding with those rules.
And you're talking about sustainability goals. Would an MBR or does an MBR help with something like, say, lead points if they're looking for certification?
I'm not sure I understand the question. Can you repeat it?
I don't know the answer to that question.
Okay. I just know that,
Derek, just MBR is proven technology. Okay. So I'm dealing with MBR from my incentive. I used to work with company Xenon we developed that product. And now it's a very commercial. There's 1,000 installations around the globe. So it's approved, it's accepted by all regulatory agencies. What's the question is how much is in a wastewater treatment and water reuse, there is certain criteria how you build your wastewater treatment facility, assemble it, and there is the criteria is called the lots removal. So MBR is credited by certain lots as a technology, and you just need to assemble the right facility if that is direction of that question, because the question is a little bit wide.
Yeah, it was a little difficult question to ask. It's just going to something like, say, LEED that has a water certification mandate, and just wondering if you guys knew that if it would help contribute to points toward that certification. But
it was a good question. Unfortunately, I don't know exactly the answer.
I think is go ahead.
I was going to say, to build a little bit more on what Val was saying there, right, is that the tech. I know Val went into this in detail at the presentation, but like the technology has advanced greatly since it was first introduced, right? And so I think what we saw in the poll was that it's a little bit of a cost and difficulty to operate, right? And the ease of operation has become much more highly automated with advances in sensors and programming. They've gotten much more operator friendly to the extent that I don't see a significant difference in operating them versus any of the other competing technologies. And secondarily, the prices come down significantly to where they're competitive. They're a little bit more expensive, but you don't have to do the follow-on treatments. So when you look at from an end-to-end treatment to get to reuse quality, they're quite competitive and sometimes less costly than other treatment systems. And I would just say third, there is also a lot more financing programs available now through leases and other more creative financial mechanisms that make it a lot easier to get into this technology within a budget.
It's also to add to that, I would like to add, it's quite interesting because I'm just responded to that poll that one of the point was that lack of knowledge and technology. It's quite interesting that we as a human, we generally quite conservative, right? And if the people never operated MBR, and it looks like it's a membrane, something more complicated technology. It's quite interesting that to operate in at least several plants, what we've seen when people were start considering MBR, it was some resistance in terms of the complication of technology. But when the MBR being installed, people were trained and operated. People actually like it more than other technologies because it's self-contained operationally, and it's way more robust and flexible compared to many other technologies, and specifically to the upsets. I can give you that example. For example, if any toxicity in the water, an industrial plant that always may happen, because of higher mass of the liquor in the MBR, it's more flexible to accommodate that, not to have the upset of the biology, comparing to any other process that operates at much lower liquor concentration. So at the end, the people actually, again, from resistance to falling in love, if I may say that.
Well,
And
talking
good
about
advice, yeah,
go ahead.
sorry, Derek, to add. A good advice, those who interested to improve the facility operation of wastewater treatment and reuse, good advice would be visit operational MBR facility. That's the best reference you can get. And you will figure out what are all those pros and cons.
Well, talking about process, can you provide some information on things like max flow rates and loads, and what are limitations on things like low temperature operation, and for that matter, high temperature operation in terms of climate?
Similar like any biological process, the MBR using biological process, the biological process itself is just different operational conditions. As we already talked about, a liquor MLSS factor is way higher than conventional, and SRT or slash tension time, it could be similar or higher. So you have more flexibility on MBR, but actually, as soon as your biology can survive, you can operate your facility. And it's quite interesting that most of the food and beverage plants, they have a quite high temperature compared to the overall environment temperature, because it's a processed water, it's industrial water. So general limitation, it's so hard to say, it's reasonable. At least it needs to be more than 0 C, because water needs to flow at the level of seawater level. But and high, at least we've seen probably 80, 85, 90 F, up to that range.
And I think one of your slides touched on this. I'm not sure. I think it was may have been one of Chris's slides when we lost him for a bit. And can you answer, either of you or one of you, how MBR water is reused in food production? Like how does that work? And if you want to touch, I know you touched on PFAS a bit, but also about removing any bacteria and other nasties that shouldn't be in there.
In food and beverage, that water is utilized or used for many applications, not related to, not in a contact with the food or beverage products. And that is the cooling towers, the for machinery, for cooling, just the cooling environment, air cooling inside of the plant, for some washing, and so on. Because to apply or use that water for, it's some plants actually using for boiler feed water, and that is quite achievement on several plants. So to use it for the potable use, because practically using the RO and UV, similar like a potable reuse water, that practically you can make that water, but probably FDA is not ready yet to approve that for the potable application at the food and beverage facility. We are not at that time. As soon as you may know that potable reuse, like direct and indirect. We're still at the beginning of that concept. As soon as that, we will get more precedents and more projects will be built, and many projects already underway. That may change, but we are not ready yet. From a regulatory standpoint, we're ready from technical and process standpoint and equipment standpoint, but we are not ready from a regulatory standpoint.
And how long do you think that a process like that takes to get into get it accepted with the regulatory bodies?
It depends how the industry and public will be accepting potable reuse. And if there is, go ahead, Chris. You want to say something?
Oh no, I was going to say. Sorry, Val, I didn't mean to jump in there. It's a great question, and it's hard to predict. I would say, though, that is accelerating. I think we all probably remember the poor rollout in Southern California of a toilet-to-tap program, and it was just poorly branded, right? To Val's point, right, we've got the technology to take most wastewater and get it back to potable standards, right? However, when you brand something toilet to tap, there is an aversion to that from a consumer perspective. There's a lot of different initiatives I won't get into here around the country, though, to get back to at least the concept. And I think as you see more and more of those better marketed and rolled out, and 1 to 2 years in, there's no hiccups, no major safety concerns, I think you're going to start to see those standards relax quite quickly. So I would probably guess in the next, 3 to 5 years, you're going to see that. That the MBR is kind of, if you almost consider it, a future proofing from future increases or more strict regulations as they come down, as well as creating more opportunities without having to go and change your infrastructure from a treatment perspective.
Yeah. And we didn't talk in the details about potable reuse because now we're considering two concepts, indirect and direct. The indirect means they have an additional environmental barrier. However, there is two direct potable reuse project already operated in Texas. It's Wichita Falls and Big Spring. And I don't know if you know, but in Nigeria, it's been built direct potable reuse, I believe, by Veolia or some French company in 1970s, I believe. Still it's ongoing. But again, as the same that Chris mentioned, San Diego is quite interesting. I remember that even toilet to tap in the media and that public perception and all that pushback. But now San Diego is actually developing project that direct potable reuse.
And do you think that as water scarcity tends to, or issues with water globally tend to increase, that might also speed up this adoption of MBR?
Yes. And all those, what we see that climate change, I don't know that global warming or global cooling, but we definitely see some changes. So acceleration that those events, that extreme events, like more dry places become more dry, or wet places more wetter, and high intensity of rain and different events in a short period of time, that may drive even more, right?
And we have a few more minutes left, so if you have a question for Val or for Chris, please be sure to get that on in. Again, if we don't get to your question this time around, or if you're listening to the recording of this, that will be posted on foodengineeringmag.com/webinars. You can email us that question, and we can have Val and Chris answer that offline. So this next question we have is asks, are you also using MBRs for surcharge reduction, or is the application specifically for reuse?
The two are interconnected, right? So absolutely, it will reduce surcharges, right? It's great biological treatment that'll help to get you into compliance with whatever your limits are in the way any other will. It'll just do it in a smaller footprint and give you much higher quality effluent that will reduce your surcharge if you're currently paying them by getting you into compliance, but it'll also do it with fewer steps and less space.
Yeah, correct.
Looks like, do we have any new questions? We don't have any new questions coming in. I'll wait a few minutes in case somebody has any additional questions coming here at the end. Also, I'd also like to remind everybody that if you check the handouts tab, we have a white paper for you called Turning Wastewater into Value for Your Business. That will hopefully, we talked about oral ROI earlier. Maybe that's something else that can help convince management that MBR is something that your business might need. And that looks to be it. So again, if you do have any questions, if say you think of something once we go offline, again, you can email your question to us and we will have Chris and Val answer that. So I'd like to thank everybody for this webinar. If we didn't get to your questions, email us. And I hope everybody that's here will join me in thanking Chris and Val for their presentation, as well as our sponsor, Integrated Water Services. Again, don't forget to grab the Turning Wastewater into Value for Your Business white paper that's available in the Handouts tab. And again, I've mentioned this many times, if you have any additional questions or comments, please don't hesitate to click the Email Us button that you can find on your console. And please visit foodengineeringmag.com/webinars for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you have found this webinar to have been a valuable experience.